Okay, so this is number 7, requested by Drew. It's a toy rocket going from rest, accelerating at 39.2 meters per second squared for the first 5 seconds, then continuing on after that. We are asked to figure out the velocity after the first 5 seconds, calculate the maximum height of the rocket, and figure out how long it's going to take till it hits the ground. Okay, so a couple things. Always positive and negative, up positive, down negative. You could do it the other way if you wish. We're given acceleration for the first 5 seconds, where no gravity, and we know that it started from rest, so these are your starting points. We're going to be using all the kinematic formulas that you have before, so this is all part of this unit. We are going to start with this one. Now, let's give ourselves some room to work here. We know that the original speed was 0. Okay? We know the acceleration is this. Okay? And we know that's up. And we know that was for 5 seconds. When we solve for that, we get 196 meters per second up. Okay. Again, notice your units. Seconds will 1 seconds will divide out, leaving us with meters per second. So unit analysis says I'm looking for a velocity. I get a velocity. I am probably doing it right. Okay, so we know now that our velocity at the end of the first 5 seconds is 196 seconds, or meters per second. So we can use that to our advantage right here. During the first part of this flight, it goes from 0 to 196. It's a constant acceleration. I can use this formula right here. So I can find out that the distance up is 1/2 196 meters per second plus 0. And I was doing that for 5 seconds. When we solve for that, we get 490 meters. Okay. Now the second part is a little different. I don't know the time, but I do know it goes from 196 to 0, because at the maximum height, velocity is 0 in the vertical. Because I don't have the time, and I really don't need the time, I can say that this is probably the formula I need. Now, here, V2, or the final velocity, is this one right here. So I'm going to say 0 right here. This is going to be 196 meters per second squared plus 2 gravity. Now, be very careful with your signs. Remember, gravity is down, so this is a negative value. And delta D is, I don't know. So that's what I'm looking for. That's good. Okay. When I solve for that, I get a displacement of 196 meters. Okay, that means my total distance, my distance from the ground to its max height, is going to be the sum of this one and the sum of that one put together. So that gives me, right here, delta D total is going to equal 490, because that was my first displacement. And then it kept going another 1,960. So that gives me a total displacement of 2,450 meters up. Okay, next question is asking for total time. Well, total time is going to be the 3 parts put together. And you have three parts if you look at the problem. You have the first part of the upward acceleration. You have the second part, which you have sort of just a free fall acceleration. And then you get the third part, which is a total free fall, which goes from the top to the bottom. So you've got three different problems, or three different parts to deal with. So your total time is going to be equal to the sum of these three parts. Now, we are given the first part's 5 seconds. Okay? So that's a given. For the second part, we can solve for it. We know that at the top it's 0. We know that we were going 196 meters per second. We do know that the acceleration here is gravity. So we do know that minus 196 meters per second over negative 9.8 meters second squared is going to equal that. That works out to be 20 seconds. Okay. So that is 20 seconds. So the second part of the journey takes 20 seconds. That leaves the third part. So for the third time, it's just falling. So we go to our falling equation. There it is. Okay, we know that when anything falls, it falls with that. Rearranging that, we know that to figure out the time it takes something to fall is this is equal to 2 times the height divided by gravity in the square root thereof. So when we plug in all our numbers for this, and remember the numbers you're going to be plugging in, it's going to be the total height, which we figured out above here, and that was 2450. So that's going to be 2 times 2450 meters over 9.8 meters second squared. And again, if you look at your units will work out just perfectly. Well, when you do all this, that comes out to 22.4 seconds for the time for the third flight. So adding it all together, and this is what you have to do. Total time is going to be 5 seconds plus 20 seconds plus 22.4 seconds, which is going to equal 47.4 seconds. And to 2 significant digits, 47 seconds. And that would be your answer. It was squished on the bottom, but there it is. Okay, there's your bottom answer, 47 seconds. Okay, and that is how you do number 7. Okay.